Hi colleagues, how are you this afternoon? I hope you're fine. Starting this video, it would be better if we read the questions first. This is a visual depiction of this problem. There is a slanted block and a cylinder. This cylinder can move up and down. When the cylinder moves down, the surface of the cylinder will touch the surface of the inclined block. The inclined block is pushed to the right. So, we are asked to get the acceleration of the cylinder. The acceleration of the cylinder moves vertically downwards. It seems we already understand what is meant by this problem. Let's discuss it. To differentiate between a cylinder and an inclined block, assign indices 1 and 2. Physical quantities with index 1 are physical quantities that apply to cylinders. After that, we can place this object into two-dimensional Cartesian coordinates. Of course, the horizontal line is the x-axis, and the vertical line is the y-axis. We just have to be careful in determining the center coordinates and coordinate signs. In my opinion, we should place the coordinate center on the contact surface, because this point will be part of the cylinder and the inclined block. For coordinate signs, the positive value of the ordinate is downward in accordance with the direction of the cylinder movement. Watch this short animation. The point on the cylinder will move straight down. Conversely, a point on the surface of an inclined block will move straight to the right. Based on the shape of the particle's trajectory, we can be sure that this is straight motion with constant acceleration. For block 1, just write y1 equals y10 plus v10t plus half a1t squared. All signs are positive according to the selected coordinate system. We don't know the initial conditions of either object. This is common in physics analysis. We can assume that initially both objects were stationary. The initial speed of the cylinder is 0. Likewise, the initial position of y10. From this we get y1 is half a1t squared. For movement of inclined blocks, x2 is equal to x20 plus v20t plus half a2t squared. Just like the previous process, the initial position and initial velocity of the point are 0. x1 is equal to half a2t squared. We can divide the two position values. Pay close attention to the animation. It can be seen that the center coordinates and the 2 points form a right triangle, where one of the angles corresponds to the slope of the inclined block. Tan theta is equal to y1 over x2. A 30-degree tan is 1 over root 3. From here, a2 is the same as a1 root 3. We don't know the values of these two physical quantities at all. We need one more equation. Analysis of motion kinematics only reaches the relationship between the two accelerations. Now, we will analyze the dynamics of the movement. Approximately what forces are acting on this object? Of course, there is a downward vertical gravitational force, and the normal force on that contact surface. You have to really understand the concept of normal force. The normal force N1 acts on the cylinder, and N2 acts on the inclined block. In order not to get confused, we will draw these systems separately. However, the forces N1 and N2 are a pair of reaction actions. Both forces have the same magnitude, n. It seems that this normal force is not in the same direction as the direction of movement of the two objects. We can decompose the normal force into vector components. On the cylinder, there are two forces acting in the vertical direction. m1g minus n1 cos theta is equal to m1a1. Based on the selected coordinate system, the direction of motion is positive. For an inclined block, there is only a force to the right, and sin theta is equal to m2a2. Enter the values for the angle, sine of 30 degrees, and cosine of 30 degrees. Is an a2 the same as a1 root 3? Multiply all factors of the last equation by root 3. Substitute the factor n half root 3 into equation 2. Next, divide all factors by m1. From the question sheet, m2 per m1 is 2. Of course, a1 is equal to g over 7. Using a gravitational acceleration of 9.8, we will get a1 of about 1.4 meters per second squared. This is the answer to this question. It turns out this problem is quite complicated. Happy learning, everyone.